Lesson 5, we are going to be looking at solving absolute value equations. And just as a refresher of what absolute value is, absolute value of a real number is just the distance from 0 on a number line. And when we're talking about distance is always positive. Even if you're moving backwards, the distance you're moving is going to be a positive value. So what this means about absolute value is that if I'm asked what the absolute value of -5 is, all they're asking is how far away is -5 from 0 on the number line. What's the distance between these two values? Well, the distance between -5 and 0 is just 5 units. Therefore, the absolute value of -5 is 5, because absolute value just means how far away is it from 0. Doesn't matter that it's to the left, it just matters how far away is it. And then that's the same thing for if I give you the absolute value of 5, well, from 0 to 5, how many units away is that on the number line? It's 5. So the absolute value of 5 is 5, and the absolute value of -5 is also 5. So from an algebra standpoint, and when we're talking about solving equations, when we look at this next bullet, if I gave you an equation that says the absolute value of x is equal to 3, well, what this means is there's actually two solutions, because there are two different numbers we could plug in here that are 3 units away from 0. So the two values that are 3 units away from 0 on the number line are obviously the +3, but what else? -3. So 3 and -3 could both be plugged into this equation and it be true, because the absolute value of 3 is 3, and if I plug in -3, the absolute value of -3 is also 3. Since there are two solutions and we have a set of solutions, not just one number, we're going to write our solution set and we're going to say x is equal to, and we're going to use these pretty brackets, and if you don't know how to draw them, try your best. And then we're going to put the two solutions with a comma in the middle and then a little bracket on the other side. I like to list my solutions from least to greatest. Do you have to do this? No, as long as you have them both there. Okay? All right, so now that we've reviewed that a little bit, let's go ahead and apply it to solving an absolute value equation. So we've got our steps here, and I've given us an example problem. The absolute value equation that we're going to solve is 3 times the absolute value of x plus 2 is equal to 12. And here's step number 1. The first thing that needs to happen when you're solving an absolute value equation is you need to isolate the absolute value expression. So the absolute value expression needs to be isolated on one side of the equation so that it's in the form of the absolute value of ax plus b is equal to c. So we want to make sure that the absolute value expression is all by itself on one side, and then it's going to be equal to some number on the other side. So if we look at our equation, well, here's the absolute value part, x plus 2. Is it by itself over here on the left? No, it has a coefficient. The coefficient is 3. Absolute value bars are not parentheses. In our warm-up today, we had parentheses we distributed, but those bars are curved. Absolute value bars are straight. You cannot distribute into straight bars. Those are like jail cell bars. You cannot get in them. Do not distribute inside absolute value bars. All we're going to do instead is use inverse operations to get rid of it. So if this 3 is being multiplied by this absolute value, how do we undo multiplication? Divide. So we're going to divide by 3. Did not mean to use that. So that we've canceled out the multiplication with the absolute value. And we're left with the absolute value of x plus 2 is equal to, now do this division, 12 divided by 3 is 4. So now step number 1 is done because we have just the absolute value expression set equal to some number. Now we get to move on to step number 2. After the absolute value is by itself, you're going to split the equation into 2 different equations. We're going to break it apart and we're going to split it into 2 equations. One of our equations is going to be set equal to positive c, meaning whatever this number is over here. And the other equation will be set equal to the negative c. And keep that in mind, that's because there could be 2, when we're just talking about distance from the center, it could be to the left or to the right. So that's why we're breaking it up into 2 equations, okay? So now let's do that step. Now that this is all by itself and it's set equal to 4, I am going to break it apart. So I'm going to take those 2 bars, I'm going to break it apart. I'm going to take what's on the inside, x plus 2, and I will set it equal to c, which is 4. And then I'm going to take x plus 2 and set it equal to the negative c value. So I'm going to set it equal to negative 4. And now, all we have to do is solve each of these equations. And now we're just doing the easy steps. This all now is reviewed. To get x by itself, I'm just going to subtract the 2. So 4 minus 2 means that one of my solutions for x is 2. And then when I solve the second equation that I created, I'm going to subtract 2. But this time I'm subtracting 2 from a negative 4, which means x is going to be equal to negative 6. And those are the 2 solutions that I could plug back in for x and this be true, right? If I plug in 2, 2 plus 2 is 4. The absolute value of 4 is 4. But if I plug in negative 6, well, negative 6 plus 2 is negative 4, and the absolute value of negative 4 is 4. So we've got these 2 solutions. We will write as this solution set. Again, I like to write them in order from least to greatest. If you don't do that, it doesn't matter. You don't need to. It will still be correct. All right, so let's try 2 more with me, and then I'll have you and your partner try that number 3. So here we go. Number 1, the absolute value of 8p plus 5 minus 3 is equal to 18. So once again, step number 1 is that this part needs to be by itself. Well, what's over here on the left with this absolute value? What's over here on the left-hand side with the absolute value of 8p plus 5? A minus 3. So I need to bring this minus 3 over to the other side. So I'm going to do the inverse of a negative 3. And I'm going to add the 3. And again, whatever I do to one side, I'm going to do to the other. So that leaves me with the absolute value of 8p plus 5 is equal to 18 plus 3 is 21. Now I've isolated the absolute value part. So now I get to break it into its 2 equations that I can solve that are going to allow me to solve for p. So I take what's on the inside, and I do 8p plus 5 is equal to 21. And then 8p plus 5 is equal to a negative 21. Now I can solve those equations for p. So I'm going to undo the constant first, so I'll minus 5. Leaving me with 8p is equal to 16. Then I can undo this coefficient. So now I'll divide by 8, which means one of my solutions for P is 2. And then when I solve my second equation, the steps will be exactly the same, but I'm going to get different results because now it's equal to a negative 21 instead of a positive 21. So I still undo this constant first, so I'll subtract 5. But this time I'm subtracting 5 from a negative 21. So negative 21 minus 5 is going to be negative 26. Good. And then still, to undo this coefficient, I will divide by 8. And I'm going to get a decimal, but that's okay. So negative 26 divided by 8. Negative 3.25. Good job. So then those are my solution set for P. So P is going to equal, use those pretty brackets, negative 3.25 and 2. That's a negative sign. All right. Let's work through number 2 together. Number 2, I have 5 times 2x plus 4 minus 1 equals 19. So again, with these absolute value, the first thing I want to do is I got to get this part all by itself. I'm just highlighting it to draw your attention to it. It's over here on the left. What's on the left side with this absolute value of 2x plus 4? Yep, I have a coefficient of 5. What else? A negative 1. I have to undo those just like I undo them in a normal equation. Constants have to be undone first, then coefficients. So this 5 is the coefficient of this absolute value, so we undo it second. We have to undo this constant first. So since this is a minus 1, I'm going to make it positive, add 1 to both sides. So that then I have 5 times the absolute value of 2x plus 4 is equal to 20. Now the only thing left over here is this coefficient. And so since this is being multiplied by 5, I will divide by 5. So that I'm left with the absolute value of 2x plus 4 is equal to 4. All of that was step number 1. All of that was to get this absolute value by itself. Now that it is, we can move on to step number 2, which is, all right, now let's break it up into 2 equations where I take what's on the inside, 2x plus 4, and I'm going to set it equal to a positive 4, and then I'm going to do 2x plus 4, and I'm going to set it equal to the opposite of positive 4, which is negative 4. Now's the easy part and not the new part, because now just solve both of those for x. So I'll subtract 4 first, leaving me with 2x is equal to, well, 4 minus 4 is going to give me 0. So then I divide by 2, which means one of my solutions for x is 0, because 0 divided by 2 is 0. And then when I solve my second equation and I subtract 4 from both sides, well, now 2x is equal to negative 4 minus 4 is going to give me a negative 8. And then that same last step, I'm going to divide by 2. But when I divide by 2, I get x is equal to negative 4. So those are your 2 solutions for x. All right, not too bad, right? Okay, so you and your partner are going to try number 3. So number 3 is very similar to number 2 because you've got a coefficient and a constant. So remember, you got to get rid of those two things first, just like we did up here, then break it into the 2 equations, then start solving for x. All right, so I'm going to give you and your partner about 2 minutes. Then we will see how you did. Okay, I saw a lot of correct answers, so that makes me very happy. Your 2 solutions for x were 2 and 8. So same thing, like the last one, we get this absolute value part by itself by first undoing the constant. So since this was a plus 5, I subtracted it. Then I'm going to undo the coefficient. So since it's multiplying by 2, I'm dividing. Finally, I get the x minus 5, the absolute value of x minus 5 all by itself. I can break it into its 2 equations. X minus 5 is going to equal the positive 3 and the negative 3. All right? Okay, so all these examples had 2 solutions because this absolute value is equal to a positive 21. This absolute value is equal to a positive 4. This absolute value is equal to a positive 3. So we saw 2. Real quick, though, we might not always see 2 solutions. So we're going to go through the different types of solutions and then quickly look at an example and then be very close to being done. When we have the absolute value equations, we could have only one solution. We will see one solution if and only if the absolute value expression is equal to 0. So if the absolute value expression is set equal to 0, well, when we go to break it up in 2 equations, we can't have 0 and a negative 0. That's not a thing. We only have 0. So that would be an example where we're only going to have one solution instead of 2. Or we can have, like we've looked at, which is 2 solutions. And we will see 2 solutions if and only if the absolute value expression is equal to a positive number. Which is why solutions every time it was equal to a positive number. The last type of solution would be if we have no solution. So we have no solution if and only if this absolute value expression is equal to, can anybody guess it? What type of number would leave us with no solution? Negative. 0 gives us one solution. If it's set equal to a negative number, well, now we're going to have no solution. Meaning, if you get to this point and you have like x plus 2 is equal to a negative 5, this is going to be an example of no solution because at the beginning of the notes, remember we talked about absolute value as distance, and distance is always positive. So there's no way that this absolute value is ever going to be equal to a negative. So if you isolate this absolute value and it's equal to a negative value, you get to stop and just say no solution. Now we're going to quickly look at one of each type. So number 4, and this is like right underneath. Like number 4 is an example of one solution. This is going to be 2 solutions. This is going to be 0. Okay? So I gave you the problems right underneath the type so you can see what I mean. So if I look at number 4, well, this time the absolute value is over here on the right, which means I need to first get this absolute value alone. So over here on the right, we have minus 8. How do we undo a minus 8? We add it, a positive. Very good. And when we add 8 to a negative 8, we get 0. Yes?
I'm so sorry. Can I please have Isabella to the guidance hub?
She's on her way.
Thank you.
So now we have 0 is equal to the absolute value of x plus 2. So when I go to break this up, well, I'm going to have 0 is equal to x plus 2, but I'm not going to write negative 0 equals x plus 2. There's no such thing as a negative 0. So I'm only going to have whatever the solution is to this one equation, which is really easy because then all I have to do to get this x by itself is subtract the 2. So my only solution for x is negative 2. I minus that 2 from both sides. X is equal to negative 2. That's it. The only solution. Two solutions are what we've been looking at. So this is going to be really quick. Just give us one more opportunity to practice solving this where there's two solutions. So let's go ahead and work through this together. Again, drawing your attention to the absolute value bars. They are not by themselves. Once again, we have a constant and a coefficient. So we need to undo the constant first, then we undo the coefficient. So we undo a plus 4 with minus 4. So I have 8 times the absolute value of 8x minus 2 is equal to, well, not yet, but yeah, 112. Then, sorry, you're ahead of me. Then we can undo this coefficient. So we've got divided by 8, divided by 8. Now I'm left with the absolute value of 8x minus 2 is equal to 14. Perfect. So this absolute value is equal to a positive number. So that tells me there's going to be two solutions. So I'm going to break it apart just like we did before. And I'm going to find those two solutions. So I'm going to get 8x minus 2 is equal to the positive 14. And 8x minus 2 is equal to negative 14. Now we just have these two easy equations to solve. So we're going to add 2. 8x is equal to 16. Then we divide by the 8, leaving me with one of my solutions for x is 2. And then on the other side, I add the 2. 8x is equal to a negative 12. Then I divide by the coefficient, so I divide both sides by 8, which means my other solution is negative 1.5. So there is one more example of solving that absolute value equation when there's two solutions. And number 6 is going to be the easiest one. So number 6, I have 3 plus the absolute value of x plus 4 is equal to 0. So if I need to get this absolute value part isolated first, well, over on this side, we have a constant. This is a constant of 3, not a coefficient because it's not touching. It's separated by an operator. So this is a constant 3. How would I undo that? Very good, negative 3. So I'm left with the absolute value of x plus 4 is equal to negative 3. Can absolute value be negative? You don't have to go any further. You can't. There are no solutions because there's no number that I can plug in here where it makes the absolute value negative because absolute value is distance, so that can't happen. Last but not least, a word problem. And I will tell you that this word problem came directly from the EOC last year. So fingers crossed, this is what the word problems look like when you see it again this year on the EOC. You've got two divers are underwater. One diver is at a depth of 32 meters while the other diver is at a different depth. The given equation can be used to find the possible depths x in meters of the other diver. So they've already given us the absolute value equation. We don't even have to write it. They said, here you go. And then it says, enter the values to complete the sentence about the diver's depth. So the second diver is either at blank or blank meters. So all I'm having to do is solve the equation. They just gave me a whole story. They gave me the equation. All I have to do is solve for x. So, and the even easier thing about this equation is that the absolute value part is already by itself. There's nothing else over here with it. So we don't even have to do any isolating before we start. I'll do it in a second. Any isolating before we break it up to find those solutions. She's in the hub. That's like the front side of the library. So we're going to break that apart. So I have x minus 32 is equal to 11. And x minus the 32 is equal to negative 11. So add the 32, which means x is equal to 43. Or if I add the 32 to a negative 11, I get x is equal to negative 11 plus 32, 21. So now that I have found the solutions for x, that gives me the depth of the second diver. The second diver is either at 43 or 21 meters. Don't know, but he's at one of those meters, he or she. So the beauty of this being the test question, and again, fingers crossed they do it similar this year, is that you didn't even have to write the equation. All you had to do was solve it. So if you know how to solve absolute value, then you should easily be able to get this one right. Okay? All right.